Every major software vendor now claims to be AI-powered. The label appears in pitch decks and product pages with enough regularity that it has essentially stopped meaning anything. The useful question for a product leader is not whether a vendor uses AI, but when it became foundational to the platform's architecture. There is a structural divide between AI-enabled products, which add intelligent features to existing legacy systems, and AI-native products, which are built from the ground up on infrastructure designed specifically for model workloads. This architectural choice is reflected in financial performance. According to McKinsey's 2025 survey, AI-native products generated 2.6 times faster revenue growth than their AI-enhanced competitors in the same market categories. When you add a large language model to an existing application, you give a human user a slightly faster workflow, providing inline suggestions, sidebar assistance, or auto-populated forms. Rebuilding the product around the model changes the entire interaction model. The AI acts as a structural component to execute tasks autonomously. If you remove the AI from an enhanced product, you still have a working tool with fewer features. If you remove it from a native product, the entire system ceases to function. This decision dictates a company's long-term unit economics and the specific skills required of its engineering teams. To understand why, look at how these systems handle data. Legacy software relies on relational schemas designed for human input. The AI acts as a downstream consumer, reading whatever data was collected, processing it, and returning text. The loop ends there. AI-native products design their schemas for machine learning from the start. Instead of relying on static relational tables, the foundation is built on embedding vectors and interaction traces. Every user interaction, every context shift, and every corrected error serves as a continuous training signal. The system captures the reasoning patterns required to solve problems, rather than just the final answers. These two different architectures yield fundamentally opposing cost structures. For AI-enhanced products, AI is a variable API cost on top of traditional hosting. Unit economics remain flat, scaling linearly. In AI-native products, compute is the primary expense. But because the system trains on usage, efficiency improves and cost per unit decreases at scale. This creates a data flywheel. The first product to reach scale accumulates specific training signals that subsequent entrants cannot easily replicate. Developing these compounding economics involves a transition from legacy relational systems toward an AI-native rebuild. This architectural foundation becomes critical as the market moves toward agentic orchestration, systems where AI autonomously executes multi-step workflows. Layering autonomous agents on top of legacy architecture introduces severe fragility. If models are general purpose and pipelines unoptimized, the agent inherits those weaknesses. A single hallucination or misinterpretation early in a process amplifies across every subsequent decision step. Reliable autonomy requires an AI-native continuous evaluation system running parallel to live workloads, validating output quality. The human role shifts from initiating tasks to supervising. They handle exceptions and provide context to the evaluation layer, training agents rather than doing the work. Without this continuous evaluation scaffolding, agentic outputs become untraceable and impossible to audit safely. AI autonomy is difficult to achieve without trust and governance frameworks baked directly into the infrastructure. Historically, enterprise software defensibility relied on gravity, the necessity of humans living inside a proprietary user interface to access the system of record. AI agents do not need a drag-and-drop pipeline view. They pull dozens of signals simultaneously from multiple applications, synthesize the information, and execute actions via APIs. Gravity is shifting from data accumulation to orchestration, creating a new system of intelligence. From the agent's perspective, the legacy CRM or ERP is just a database. The system of record is becoming a commoditized background persistence tier. This forces a reevaluation of classical business modes. Because agents can automate data migrations and translate business logic across platforms, traditional switching costs are declining. At the same time, raw model intelligence provides little defensibility. Most teams can build a thin wrapper around a foundation model's API. The durable advantage in the agentic era is process power. Application software is essentially a stored process. Defensibility comes from building orchestration scaffolding that reflects an enterprise's undocumented workflows, strict compliance rules, and institutional preferences. Defensibility does not come from hoarding data in a static database. It comes from mastering the complex execution of real-world enterprise processes. Navigating this transition requires a structured framework, like McKinsey's 3 horizons of growth. Horizon 1 represents legacy, AI-enabled optimization that protects market share. Horizon 3 is where you fund exploration and build the parallel AI-native architectures required for future growth. As you deploy these new architectures, the business model must change. Traditional per-seat pricing is difficult to maintain when you sell autonomous agents that eliminate the need for human seats. To survive the pricing pressure of falling inference costs, companies are shifting to value-based pricing. Charging per resolved ticket aligns revenue with economic outcomes. To bypass long procurement cycles, high-performing vendors often discount the upfront proof of concept. This lowers the entry barrier without sacrificing long-term contract value. Once deployed, product-market fit must be measured differently. Traditional 6-month retention curves are too slow. AI-native products require immediate usage data to train models. High-frequency user engagement is the primary leading indicator, showing how often users perform core actions early on. Tracking these engagement loops ensures you spot friction early, preventing you from starving your models of the training data they need to compound in value. Failing to adapt pricing structures and measurement frameworks will lead to being outmaneuvered by competitors who understand the new economics. The software industry is expanding as AI automates workflows that were previously considered too complex or expensive to touch. Owning the database interface or providing a polished user dashboard will no longer guarantee survival against headless, agentic competitors. The companies that endure will combine an AI-native data architecture, robust continuous evaluation for trust, and deep, context-rich process power. It is time to stop asking how you can add artificial intelligence to your existing products. You must begin designing your workflows, your infrastructure, and your business models under the assumption that autonomous AI is always present.